Okay, welcome to E2 Part 2. What we're going to talk about in Part 2 is how Earth's surface processes shape the crust of the Earth and form those amazing geological features that many of us have had an opportunity to visit here in the United States. So what we're going to do today is we're going to start in on this presentation, which I will share with you also without narration in case you get tired of listening to me talk. And what I'm first going to point out is that this first section of the presentation talks about the hydrologic cycle, which is also known as the water cycle. And you will have a quiz for Part 2, but your quiz will not include the water cycle. The water cycle is probably something you've studied before in middle school. It's extremely important in the process of shaping Earth's surface, but we aren't going to actually quiz on it. So there's some great slides here at the beginning that I would encourage you to kind of review, but we are not going to ask you to remember what condensation, precipitation, transpiration, etc. are. So there's a little video if you'd like to watch that as well. Some great diagrams, and maybe in a later unit you'll want to come back and look at that. But the reason water has often been included in this unit is because water is the number one agent of altering Earth's surface structure. So like I said, some great slides there, but we're not going to cover it in a quiz. So if you want to read about it, please feel free. Some of those terms may be important to you as you work on your project. But for today, we're going to just jump right into Part 2. So in Part 2, Target 8.8, it talks about the different types of weathering. All right, welcome. Today we're going to jump right into Target 8.8, where we're going to discuss the types of weathering and talk about some examples of each. So there's two types of weathering, but before we get into that, we have to make sure that you understand what weathering itself is. So when we talk about weathering, we're not talking about the app on your phone that tells you the temperature and if it's going to rain. What we're using is a term called weathering, which means to break materials, usually that's rock, into smaller pieces. Now, it might be something that's gravel and you're breaking it into sand, or it could be soil and you're making it into silt. But when you take a substance that's on the Earth's surface and you physically break it into some other smaller piece, you are doing what is called weathering. And there's two major types of weathering: chemical and mechanical. And so we're going to take each of those one by one, and we're going to talk about what they are and then give you some examples. All right, chemical weathering uses a chemical reaction. So I know we haven't necessarily done chemical reactions in chemistry yet, but when you talk about a chemical reaction, you're changing the composition of the substance. So there's some form of a chemical reaction taking place, and just keep that in mind for when we get to that chemistry unit. All right, so what are some examples of chemical weathering? There's three major types: oxidation, hydrolysis, and dissolution. And so I'll show you some pictures of each and explain what the difference is. Primarily what you're doing is you're looking at a different type of chemical reaction. So it's the substances that are involved in the chemical reaction that tell you what type of chemical weathering is occurring. So in this example, we've got oxidation. And oxidation is when oxygen in the atmosphere chemically reacts with minerals or substances, and it breaks down the substance. Again, typically a rock. So oxidation is what you and I would typically call rusting. And you're thinking to yourself, well, how does a rock rust? Well, metals rust, particularly metals that contain a lot of iron. So there are, where does iron come from? Earth's surface. We mine it and then we refine it and we use it to make things like your bicycle. So you don't leave your bicycle outside and let it get in the rain because it'll rust. You have to be careful about your patio furniture because it might rust, or your grill. Well, what's happening is the metals in those items are reacting with the oxygen and they're rusting. But iron is naturally found in Earth's surface, not as much as in the core, but there are some. And if you have a substance such as a rock, it can actually rust when exposed to oxygen, and that is called oxidation. Hydrolysis is when you have a chemical reaction between water and silicate minerals that break down the actual rock. And so we're getting a chemical reaction between water and the compounds that are found in these rocks. And a lot of times you'll see this on statues or tombstones in a cemetery. And we start to lose the definition of the carvings or the letters. It's a little harder to see in like a non-man-made situation, like not a statue. But you can see here the surface of these rocks has been altered by the chemical reaction of the water and the silicate. That again is hydrolysis. And the third type of chemical reaction is dissolution. And dissolution occurs when you have carbon dioxide in the atmosphere and water, and carbon dioxide and water come together to form carbonic acid. And the carbonic acid then dissolves the rocks. This occurs a lot when you have limestone or rocks that have a lot of calcium in them. And so when it dissolves the rocks, it forms the caves. And then as a part of that, you get all these other features like stalactites, stalagmites, sinkholes, caverns, etc. But the actual dissolving of the rock and changing it, the substance is actually called dissolution, and that's due to an acid. All right. The second type of weathering is called mechanical weathering, and mechanical weathering is a physical process. So we're going to change the size, shape, or texture, but we're not going to change what the rock is made of. So there's no chemical reactions that occur in mechanical weathering. And if in middle school you remember chemical versus physical changes, when we talked about chemical weathering, we were talking about chemical changes, and mechanical weathering is all physical changes. So there are some different types, and I'll show you this list. And the most common are frost or ice wedging, thermal expansion and contraction, mechanical exfoliation, abrasion by particles such as water, wind, or ice, root wedging due to plant growth, animal actions, and actually human activities can sometimes be lumped in with animal actions depending on whether you want to lump us with the gophers or not. But there are many different ways that physically Earth's surface is changed. And so what we'll do is we'll go through each of these 7. I'll show you some pictures, and we'll try to give you some examples and define what's actually happening in each of these 7 types of mechanical weathering. All right, frost or ice wedging is when water, and that can actually be a lot of liquid water or it can just be kind of frost, gets into cracks and crevices. And just like if you put a pop can in your freezer, it'll expand and explode. When you put water into a crevice, if it freezes, it can actually expand by up to 10% of its volume. And that actually forces the materials apart. So you can see here we've got a rock and it's got some cracks in it, and the water and the rain and maybe the snow gets in there. And then as the temperature decreases and it forms ice, it's like literally a natural chisel or a wedge, and it breaks off the pieces. And this is one of the reasons why you want to seal your asphalt driveway and not have cracks in it. This is also one of the reasons why we have to be real careful if you've got a crack in your foundation, because if you live in a climate where you get freezing and thawing, water can get in there and make it worse. Okay, so here's a picture of frost wedging in the soil. So there's actually ice crystals in the soil, and as it freezes, it's actually kind of stirring up and fluffing the soil. So when this actually melts, the soil will be in a smaller or finer texture than it was to begin with. All right, thermal expansion and contraction is a really neat one to see. I saw this out west when I was on a trip once. And this occurs in climates where you get a lot of heating and cooling. So here in the Midwest, we have cold winters and warm summers. So we would be prime example of thermal expansion. And this is where you might notice sometimes in the winter, your doors or windows at your house open and close differently than they do in the summertime. And that's because objects expand when they get warm and contract when they get cold. The exception to that rule is water. And so as things continue to expand and contract, you get cracking. And so if you've ever watched somebody do concrete, okay, and my family does some concrete work, so he will actually put expansion, rubber joints in between the pieces, because he expects over the wintertime that those pieces of concrete sidewalk, driveway, etc., will expand and contract. And so we actually put the cracks in there on purpose so that they don't cause undesired cracks and damage your landscaping. But we see this actually occurring here in a real rock. All right, this one is called mechanical exfoliation. And mechanical exfoliation often occurs on igneous rocks. So if you have an igneous intrusion, meaning you have lava that actually oozes a very scientific word, into the Earth's crust, we get what's called a deep pluton. So this is an igneous rock in Earth's crust under the surface layer of soil and clay and things. And so when these layers on the top wear away due to other forms of weathering and erosion, so when we lose that surface layer and our igneous rock is exposed, then when we have changes in weather and climate, it'll actually crack off pieces of the igneous rock. But what's unique about this is it peels off kind of like the skin of an onion. So if you've ever had an onion, the outer layer is dry and they peel. Mechanical exfoliation is a lot like that process, but it occurs in rock. And I'll show you a picture of that here on the next slide, because you end up seeing kind of a rounded effect. So it cracks and it peels, and then gravity pulls them down to the sides, and then it continues just like the layers of an onion. So here's a picture of an exfoliation dome, and as these pieces here become loose, they'll actually, due to gravity, fall towards the bottom, and so you get these kind of sheets of rock coming off. This is a really neat one to see in person. All right, and then we have abrasion. If you've ever been to the beach, boy, would we like to go to the beach now. The waves come in and out. Okay, so as the waves come in and out, they run over the sand and the rocks. They also bring the sand with them. And so it's almost like sandblasting these larger rocks. And if you've ever noticed, the rocks along a lot of beaches like this are very rounded because they have undergone abrasion. Beach uses water and sand. You can also see ice from like a glacier do this. And places that are very windy, you'll see things like wind abrasion. So the dust and the sand in these arid, dry climates is picked up by the wind, and then the wind hits this, just like if you stood outside in a dust or a windstorm, it hurts your face. Well, it hits these rocks, and the softer types of rocks wear away faster than the harder types of rocks. So you can see there's different types of rocks in this. We've got the red rock. Here, there's a layer here that's kind of a brown. We've got a layer that's red. And so each of those layers, based on its hardness, deteriorates or weathers at different rates. But this would be an example of wind abrasion. All right, this is wind and water creating some arches near a coastline. We also see some wind arches famous in the west, okay, down by Arizona. All right, root wedging. Someday you're going to own a house. My advice to you is don't plant your trees too close to your house or your sidewalks, because the roots grow, and slow and steady, what they actually do, they'll force apart those sections. And so you can get cracks in your foundation, or you can get lumps and bumps and heaving in your sidewalks. And if you've ever rollerbladed or used your skateboard on a sidewalk, or even your bicycle, you'll probably notice this. But the roots actually grow in, and so while we couldn't actually lift this rock, over time, the roots of this tree are actually pulling apart this rock. And you can see that also if you've ever gone along the Rock River, Oregon, Illinois, you'll see the rocks growing into the cliffs. It's very interesting there. So we see it naturally, but my word of advice is don't plant your trees or your bushes too close to your house or your sidewalks. That's called root wedging, or AKA sometimes called root pry. All right, and then we've got animal actions. This is a groundhog, which creates quite a burrow. This weekend, I actually saw some coyote dens. Okay, those also, and you may have had the unfortunate situation of having gophers in your front yard, and you get all those little ruts and things. These actually look like domestic pigs. These don't look like wild pigs, but wild boars are also a nuisance that create damage to Earth's surface. You hear of wild boar hunts, places in Texas and down south. We don't have wild boar up here in northern Illinois. We have more domestic. But we do. I do remember as a kid when my father's pigs would get loose, my mother was always in an uproar about her flower beds. And when I let my animals out in my yard, they definitely leave a lot of rooting and footprints, and they make a mess. So you could include humans in here. You know, we go hiking, we ride our bikes. We use things like for me when I go horseback riding, or if you use a dirt bike or a four-wheeler. Even boating actually causes waves in certain places. So humans contribute to changes in Earth's surface as well. All right, that concludes the discussion of chemical versus mechanical weathering. But one of the things you want to do in Target 8.9 is be able to do a compare and a contrast. So one of the things I suggest for that is a Venn diagram, and you can do this digitally or in your notebook. But list one is chemical, one is weather as mechanical. Tell me how they're similar, tell me how they're different, and then can you practice providing some examples of each? And that is a great way of kind of just manually pushing your brain through that exercise of keeping track. All right, we'll sign off for now, and we'll come back later and talk about Target 10.